So now for point B, similar way, if you are going to consider point B, the forces that we have to show here, first force, which is nothing but the force acting in member AB. So this way I'm going to show this force in member AB, then force in member BC. All forces I'm going to show away from that point, then force in member BE, then force in member BD, and external forces also. So whatever the external forces are there, that also we'll have to count while solving that problem. So this way I just listed all these forces. That is, first one, force in member BC, force in member BE, force in member BD 1 kilonewton, and force in member AB. So this is what our second free body diagram. And if we observe here, if you are going to select this point B, there will be 1, 2, 3, 4 unknowns. So in earlier case there were 2 unknowns, and now in this at this point there are 4 unknowns. So now we are going to see what if we are going to take this point C, or we are going to consider point C. So when we are going to consider point C, there will be force in member CE, force in member AC, force in member BC. So out of that, once again I will draw this free body diagram over here so that will be more clear. Point C and forces acting at point P, external forces as well as the forces in members. So force in member CE, force in member AC, and what else? Force in member BC. So all forces we should show away from point. So now this is what our force in member C, force in member BC, force in member AC. Okay. So now in this at this particular point there are 1, 2 and 3 unknowns, while as in our first case there are only 2 unknowns. Still it means what? The option 1 is better for the selection. Okay. Then once again we will draw the free body diagram for this point E. So while drawing free body diagram for point E, force in member EF, force in member ED, force in member BE, and force in member CE, and as well the external forces. The external force here is reaction. So all these things we have to show here into this at this particular point. So this is what our point E. For this point E, I am going to show all forces. So I will simply write it down, that is reaction at point E in vertical direction, then force in member EF. Now if you are going to select this point E, only REV is known from our previous step and rest of the forces are unknown. It means there are the 4 unknowns. So in this diagram there are 4 unknowns. In this third diagram there are 3 unknowns. Fourth diagram 4 unknowns. Now similar way free body diagram for this point D, if we are going to consider force in member BD, force in member DE, force in member DF. So we'll draw that free body diagram over here. That is force in member BD, then force in member DE. This is all about our point D. And for point F, same way we can show all these forces at this point F. This force in member actually it is DF, and for this point D also here it should be, and external forces 1 kilonewton and 1.5 kilonewton. Now according to our first step, we have to select the individual joint and apply the conditions of equilibrium, whereas the joint should be selected in such a way that there should be minimum unknowns. So in first equation or the first figure there are only 2 unknowns, while as REV and RAH we already calculated here in our previous step. Then in our second part, or in our second figure, there are total 4 unknowns, so we can't select this as there are the number of unknowns are 4. Here there are 3 unknowns. In figure number 4 there are REV, calculated in previous step. So altogether 4 unknowns. As well, in this figure number 5, there are the 3 unknowns and 1 known force. It means what? 3 unknown forces. And if we are going to select this point F, there will be once again 1 and 2 forces unknown. It means what? Choice is there between point to figure number 1 and figure number 6. So we can select any of that figures. So first of all we will select, we can select simply first figure and apply conditions of equilibrium over there, and we can calculate the rest of the things. Now before we have to start this calculation, we need to know this theta so that we can use this condition of equilibrium. So in our next step, conditions of equilibrium, that is summation of all forces in x direction equal to 0 and summation of all forces in y direction is equal to 0. Now before that we need to know this theta. So for this theta we can just observe this diagram. So before this we need to calculate this theta so that we can use it further. So theta is nothing but the angle for this member AB. So if we are going to observe this line AD, it is as well AB only. So the angle of AB will be equal to AD. So we can select any triangle which is going to include that theta for which we have to calculate and see, because I'm going to finalize this triangle because maximum parameters are known from this triangle, that is 4 meter, one side is known and this another side is also known. So from that thing we can calculate this theta. If I'm going to finalize this small triangle, from there from this triangle also I can get this theta, but in that case one side is known, this side is not known. So it means what? Any two parameters we need to know to calculate that theta. So if you have to calculate this theta in these terms, we can get this theta by using theta is equal to tan inverse of 4 divided by 8, that is equal to 26.56. So this theta is, so now we can use this first condition, and from that first condition we can get this answer. So sum of all forces in x direction, that is equal to 0. This is nothing but all forces in x direction, that is according to sign convention, that is RAH sign convention, we are going to take according to the coordinate axis, that is all forces acting along positive direction of x-axis are going to take it positive, all forces acting along positive direction of y we are going to take positive, forces acting along negative axis, that should be minus, forces acting along negative, that will be y direction, that will be minus. So accordingly RH will be plus, then force in member AC, that force in member AC, and then x component of this force in member AC. So x component, when we are going to resolve this force here, that way FAB cos of 26.56. So if we are going to resolve this force AB, so this force can be resolved at this point only, and that magnitude will be AB cos of 26. It means what? X component of this force and y component of this force exists. So that's why we are going to consider the x component of that inclined force as plus, and that is equal to 0. So in this equation, if you see the first force, that is RAH, earlier we have calculated, and RAH value is it is minus 1.5 kilonewton. So this RH value is minus 1.5 plus FAC, force in member AC, plus force in member AB cos of 26.56. Now this is equal to 0 as per the condition of equilibrium. This is equal to, we are going to finalize this or rearrange this equation, force in member AC plus force in member AB cos of 26.56 6 and this minus 1.5 becomes this side. So this is what our first equation. Similarly, I can use this second equation, sum of all forces in y direction equal to 0, and let's see which are the forces that I can count here into the y direction. So for y direction I will have to use RAV and vertical component of FAB. Okay, it means what, this one. So that equation will become reaction at point A, vertical reaction at point A, plus y component of, plus here y component of this AB, that is force in member AB sine of 26.56. After resolving, whatever y component we are going to get for AB, that we are going to use over here, and that is equal to 0. Then earlier we just have calculated this force in member RAV. RA vertical is minus 0.75. Put up this value here, minus 0.75 is equal to FAB sine of 26.56. So that's why FAB is equal to 0.75. This will become plus here. I just have rearranged that equation directly. That is RAV value was minus 0.75. I have kept it at this side, so that's why this becomes plus, so 0.75. So the answer you will get for this, okay, so 0.75 divided by sine of 26.56. don't forget to put up brackets. That is 1.67 kilonewton. Force in member AB we are getting as 1.68 kilonewton. So this is what our value from this second equation. Now we have one more equation available, that is FAC plus FAB cos of 25. So from this equation put up this value. So after putting up this value for FAB, we'll get, this is FAC 1.5. so the value for FAC is equal to, that is 1.5 into 1.68 cos of 26.5, it is 2.25. Force in member AC. So this is the value we got for member, force in member AC. From this part here we got here value from this first joint AB, and AC value we got here. Now same way we have to choose second point, and for the second point also the similar steps we can apply, that is the choose point wherever there are the minimum unknowns. Now whatever values we got, by using those values we can choose the another point. So here now next point is either it is point B or either it is point B, either we can select this point B or point C. So for point B, now if you are going to say point B, FAB is known because we have just calculated it over here. Then FBC, which is not known, F force in member BE, that is also not known, force in member BD, that is also not known. It means what, there are the three unknowns. Now move to this point C. If you are going to move this point C, force in member AC, that is this one. So this force already we have calculated, so we will use that value here. So there remains two unknowns. So either C we can choose, or once again at point F also there are two unknown in earlier step we have seen. So any of the point we can choose. So we will select this point C. See, there's no such restrictions. If same unknowns are there, then we can go for with any joint. So it's a open choice. So FBC. So suppose I'm going to consider this point C and will apply the conditions of equilibrium as that we have applied for the second figure. Now for this point C, once again I will simply write down apply conditions of equilibrium at point. So for point C also we will get, that is summation of all forces in x direction is equal to 0 and summation of all forces in y direction is equal to 0. As this is concurrent force system, we can't use that third condition, moment of all forces in y direction equal, or moment about any point equal to 0. So that condition we can't use here because it is the concurrent force system. Out of that, this is what the first part, summation of all forces in x direction, that is equal to 0. So as per this condition in x direction, there are 1 and 2 forces. So it means what? I will simply apply these 2 forces here and we'll write down this equation, that is force in member CE, and sign convention will be plus as it is acting along the positive direction. Force in member AC, and this is acting along the negative direction. So force in member AC, and as per the condition of equilibrium it is equal to 0. Now I will simply put up that values here, that is whatever value we have calculated as it is, we will have to put up here into this equation. Whether it is plus, so we'll have to put it up plus. If it is minus, we will put up the minus value here in this equation. So first of all write down the equation and then put up the values. So force in member CE is equal to force in member AC, whereas force in member CE we have calculated as, or force in member AC we have calculated as 2.25 kilonewton. Okay, so this is what our next answer we got here. Then condition for sum of all forces in y direction 0. So in y direction only one force is there, so it is force in member BC, that is equal to 0. So this is another value we got here. So from this point we got CE, force in member CE, and force in member BC, that is this one. So this is what our third figure. Now once again we can move to the next point. Either we can choose, now this point 1 is done, point 2 is also done, and now we can proceed with this. There's the next option. This next option is either point B or point E or D or F. So if you are going to choose this point B, what will happen? So if you are going to choose this point B, there will be force in member AB is known, force in member BC, that is here. So that force we just have calculated now, force in member BC. So this we just have calculated, force in member BC. So now that force in member BC is known, force in member we have calculated from this figure, and only two unknowns are there now, force in member BD and force in member BE. So we'll apply and we can choose this point also, whereas there are the two unknowns. Now while starting solving this program, once again we need to just trace out what are the angles between this FBD and force in member AB. Already we have calculated what is the angle of force AB. Angle of force AB is 26 point. Angle of force AB we have calculated 26.56. So this is what our 56. And force in member BD, its angle will be also 26.56 only, because from the geometry we can see AB and BD are along the same line. It means whatever will be the angle for AB, that will be the angle for AB and BD, this one. Okay, so if you observe here, so BD and AB are what collinear, so are acting along the same line, so that's why the inclination of both of these forces will be same. So this is what the force values we got. Now that of for this force also we need this inclination, let's say this theta 2, that is for force BE. So check out for BE what will be the angle for BE. It means what here, if I am going to calculate this x-axis here, so this angle we want here. So from the geometry if we see, this is what our theta 26.56 that we have calculated, and this is 4 meter and height is similar. It means what, these are what equal triangles. So whatever angle it is here theta, that will be same angle over here theta, right, with respect to x, and this angle will be also theta, because these are all the alternate angles. Okay, so this theta and this theta will be same. It means what? Whatever theta for BE we have to use at 26.56. So theta 2 is also 26.56. For this second figure, we'll apply condition of equilibrium. Apply COE at point. So sum of all forces in x direction equal to 0. Sum of all forces in y direction is equal to 0. Now for this sum of all forces in x direction, so the number of forces which are inclined, first of all resolve it. So FBD will be having one resolve component here, that is FBD cos of 26.56. then this is also one x component here. So when I am going to calculate this sum of all forces in x direction, I will use the equation here, that is force in member BD cos of 26.56, as well force in member BE and its x component, that is force in member BE cos of 26.56. So I will use force in member BE cos of 26. Once again the x component of force in member AB, that is this also we have to use force in member AB cos of 26.56. This also we can use in our equation, that is plus minus force in member, and as per the condition of equilibrium this has to be equal to 0. Now put up all those values whatever we have calculated. Now we have a value of AB only. So in this equation there will be two unknowns, that is force in member BD cos of 26.56 plus force in member BE cos of 26.56. This is equal to, I will take this that side and just check out what is the value for force in member AB that earlier we have calculated. So force in member, it is 1.68. So this will become minus of 1 point, because this will come up at this side, this will become plus FAB cos of 26.56, and whereas sign convention of FAB is minus, because this value is given 1.68 only, not minus. So 1.68 cos of 26. So this is the first equation that we got here from this first condition. In the same way we can use the second condition and write down that equation for the sum of all forces in y direction. For y direction, now we have to use external forces also, that is in y direction one external force. It means what? Here for y direction 1 kilonewton we have to consider, force in member BC we have to consider, and y component of this BE, y component of this BD, and y component of this. It means what? This 1, 2, 3, 4 and 5. These are the 5 forces we have to use in our y equation. This will become 1 kilonewton is acting along the minus direction. It means what? Minus 1. Then plus this y component of FBD, force in member BD sine of 26. Then y component of this BE, which is minus force in member BE sine of 26.56. B is done. Then force in member BC, that is minus of force in member BC. Then y component of this AB minus of force in member AB sine of 26.56, and as per the condition of equilibrium it has to be equal to 0. Once again I will rearrange this equation. And we'll keep all these terms for BE. Now in this equation also there are only two unknowns, because FBC and AB we have earlier calculated in our earlier step. So I will also write it down in terms of BE and BD. So what are the coefficients latter we can use? Force in member BD sine of 26.56 minus force in member BE sine of 26.56. I will keep this force in member AB at this side, so this will become plus, and value for AB is 1.68. 1.68 sine of 26.56. This 1 also I will take at this side, plus 1, nothing else, that's it. And force in member BC, this also will become plus, and value for force in member BC we just calculated as 0, so plus 0. Now this equation will become force in member BD sine of, so this is equal to, you can simply calculate this thing, it is 1.66 sine of 26.1.75. So the value we are going to get here 1.75. So from this diagram we got here these two equations, that is first equation and this second equation, or this second equation. Now if you observe in this first equation, BD, BE is unknown, here also BD and BE is unknown, so we can simply solve this equation here, or I will simply write down this equation, second equation also there, the first equation. It is the second equation, and first equation I am going to write it down, force in member BD cos of 26.5, this is equal to 1.68 cos of 26.56, this is equal to 1.50. This is our first equation. Now we can solve this equation by using the equation mode. So to solve this equation, okay, so all BD terms I am going to consider BD as x, BE as y. So the coefficient of BD and coefficient of BE, and this is nothing but 1. So for this equation I can use equation mode, simply go to this setup and then use equation mode, first one. Now whereas this A is nothing but the coefficient of BD, or first coefficient of, it means A will be sine of 26.56. I can just use sine of 26.56. okay, this is what first coefficient. Now this is the second coefficient B, that is minus of BE, minus of coefficient of BE is minus sine of 26.56, and C is nothing but the constant term, and C is 1.7. Now second, that is coefficient of FBD cos of 26.56. Then second coefficient is also cos of 26.56, cos of 26.56, and constant term is 1.50. Now we'll get values equal to x is equal to 2.79 and y is equal to minus 1.11. So x is 2.79. X, it means what? FBD is 2.79. FBD 2.79 kilonewton, and force in member PE will be equal to, what we have finalized is minus 1.11 or 12, minus 1.12 we can take. Both these values we got here. So this is all about point B, and this way we can keep on selecting all those points whichever are required. So this way you can just complete this problem and just solve it for all points. So now what will be our next step? Our point figure number 1 is done, figure number 3 is also done, 2 is also done. Now there could be the option between either point E or either point D, and last point is F. So we can choose any point. For E, if you are going to choose this point E now, because in this figure we have calculated the forces in this point BE, and BD is what we have calculated here. So check out, if we are going to use BE and BD, can we choose this point D now? If we are going to choose this point D, BD which we have calculated, DE which is not known, and DF, it means what? Two unknowns are here. So there are two unknowns. If there is any other point where only one unknown is there, we can go with that point. but here in every case we are going to get two unknowns and not less than two unknowns are there in at any other point. So that's why choice is there between for the only two unknowns only. So this way you can solve the rest of the points and can get the values here. Okay, the steps that I can summarize here at last, so that you will get a complete overview of this topic. That is, okay, so once again you can simply write it down all these steps all together, so that you will get a complete overview for these problems. So in method of joints, what we did in first step, we have checked the stability by using m is equal to 2j minus r. Okay, then in second step we just have calculated reactions for all points, reactions at the supports by using the condition of equilibrium. And in third step we have selected each joint separately, and for that each joint we applied conditions of equilibrium and we got values for the different members. And while choosing that joint, what we have kept earlier, that is minimum unknown should be there at the point wherever we are going to select it. And at last we have repeated these steps, step number 3, for all other joints. Okay, so we'll be just going to give you the next session on method of sections, and the similar way we can just use the method of sections to calculate the forces in members, and in that also in the specific members. Okay, so till that time just stay tuned up with this channel and subscribe. Thank you.